Welcome to MRL. This is the second part of the study of theorems on chords related to properties of chords of a circle. Now in this theorem, we have to prove that equal chords of a circle are equidistant from the center. What is the meaning of that? We are given a circle with center O and the two chords AB and CD are equal. Now we have to prove that the distance OP and OQ are equal. That means the two chords are equidistant from the center. Now let us see how to prove it. Now given circle with center O, AB and CD are equal chords. OP is perpendicular to AB and OQ is perpendicular to CD. OP is perpendicular to AB and OQ is perpendicular to CD because we have to always find the perpendicular distance of the two chords from the center. Now let us assume that AP and CQ is equal to L because chord AB is equal to chord CD. Half of chord AB and half of chord of CD are equal because P is the midpoint of AB, because when we draw a perpendicular OP to AB, it bisects the chord AB, and so also OQ is perpendicular to CD, it bisects the chord CD. The chord AB and chord CD are equal, therefore half of chord AB and half of chord of CD are also equal, therefore AP is equal to CQ is equal to L. So please remember that. Now to prove this, join OA and OC. When we join OA and OC, we get two triangles, triangle AOP and triangle COQ. In triangle AOP and triangle COQ, OA is equal to OC because they are radii. Angle OPA and angle OQC is equal to 90 degrees. That is because OP is perpendicular to AB and OQ is perpendicular to CD. And also AP is equal to CQ, just we have discussed that. Therefore, in triangle AOP and triangle COQ, we have by RHS congruency, the two triangles are congruent. If two triangles are congruent, then the corresponding sides are equal. Therefore, OP is equal to OQ. Therefore, the perpendicular distance of the two chords AB and CD are equal. That proves the theorem that equal chords of a circle are equidistant from the center. A very simple proof. Try to remember that. Now the next theorem. It states that chords equidistant from the center of a circle are equal in length. Now the theorem is very simple. We are given a circle with center O and there are two chords AB and CD at equal distance from the center. That means OP is equal to OQ. Now we have to prove that the chord AB and chord CD are equal in length. Now let us see how to prove it. Now given circle with center O, AB and CD are two chords from the center and they are equidistant from the center. That means OP is equal to OQ. Now we have to prove that chord AB and chord CD are equal. Now join OA and OC. Now in triangle AOP and triangle COQ, OA is equal to OC because they are radii and OP is equal to OQ, which is given to us, and that is the perpendicular distance, and the angle APO and OQC are equal to 90 degrees because OP is drawn perpendicular to AB and OQ is drawn perpendicular to CD. They are the perpendicular distances, and therefore by RHS congruency criteria, we have triangle AOP and triangle COQ are congruent, and because the two triangles are congruent, their corresponding sides are equal. Therefore AP is equal to CQ. Now we know that if AP is equal to CQ, P is the midpoint of AB, Q is the midpoint of CD. If I take 2 times AP, then that becomes a chord AB. If I take 2 times CQ, that becomes chord CD. Therefore AP plus PB is AB and CQ plus QD is CD because P is the midpoint of AB. As we know, the perpendicular drawn from the center to a chord bisects the chord. Therefore AP plus PB is equal to AB and Q is the midpoint of CD. Therefore CQ plus QD is equal to CD. So that is what is the proof, because in this theorem we have proved that AP is equal to CQ, double of AP is AB, double of CQ is equal to CD, therefore AB is equal to CD, and that is the proof of this theorem. So these are important properties of chords, and the proof of those properties in the form of theorems, if we have learned them in different parts, please go go through all the parts, try to remember the properties, and it's very important for us to remember the properties of circles and the properties of chords and the various terms which are related to circle and the chords. So by that knowledge we can understand these theorems very easily. So please remember and note down these in a book for your future reference.